Lunar development has a problem. I made it clear in the last video that lunar development can benefit humanity in many ways. So what is the problem here? Well, how do you make money in space through capitalism while making the cost of space investment from lunar-derived materials cheap? This is a question that I have been pondering for a bit, and I think I've made a system that solves the question posited above. The system goes like this. You base the cost of everything lunar-derived off of the cost of energy to make something and move it somewhere. More specifically, you calculate it by the kilowatt hour, similar to how utility companies calculate your power bill. For example, the energy needed to make a metric ton of steel is 5,000 kilowatt hours, and the energy rates are set at 5 cents a kilowatt hour. That means a metric ton of steel will cost $250. But you need to export it to low Earth orbit, which would take more energy than just producing it and selling it on the moon. So how much would steel exported to low Earth orbit cost? To calculate this, we need to know several things. 1. The cost to make the steel. 2. The delta V required to get to the low Earth orbit. 3. What type of vehicle is being used for the transfer. 4. How much fuel it takes to get to low Earth orbit. 5. What fuel the vehicle is using. 6. The cost to make the fuel. 7. How are we getting to low lunar orbit from the lunar surface? 8. The energy cost to get everything to low lunar orbit. 9. How much mass we're sending to low Earth orbit at once. And 10. The cost of a kilowatt hour. For the vehicle, it will be an oxygen-fed Hall thruster solar electric tug. Let's assume this tug has a cargo mass of 500 tons, a dry mass of 50 tons, running at an ISP of 2,000 seconds. Such a ship will require 205 tons of liquid oxygen to push the ship to low Earth orbit from low lunar orbit. Since it is being sent to low Earth orbit from low lunar orbit on a low thrust trajectory, it will take about 6 kilometers a second of delta V to get there. I won't talk about the design specifics of such a setup, but I will display all the information of the ship on the screen for those who are interested, along with the other information to keep track of everything I said. I won't be including the energy costs to make the vehicle, and be purely looking at the cost to simply launch everything to low Earth orbit from the moon. For the method of getting to low lunar orbit will be through a mass driver. I'll assume each mass driver launch is done in 50-ton batches, and only 50% of the inputted energy is actually turned into delta V. Ready for some numbers? Well, too bad. The total energy cost to export 1 ton from the moon to low lunar orbit with a 50% efficient mass driver is going to be 623.64 kilowatt hours a ton. The energy cost to produce a metric ton of liquid oxygen is around 350 kilowatt hours a ton. As a result, the total energy cost will look like the following. The cost to order all the fuel to low lunar orbit will be 199,441.3 kilowatt hours. At 5 cents a kilowatt hour, oxygen will cost $17.50 a ton on the moon, and mass driver launch will cost $31.18 a ton. As a result, the total fuel costs will come out to $9,972.06. The energy cost to get all the cargo to low lunar orbit will be 311,820 kilowatt hours, coming out to $15,591 for 500 tons to low lunar orbit, with the total launch cost coming out to $25,563.06, coming out to a shipping cost per ton to low Earth orbit being $63.41, which is cheap compared to Starship's $50,000 a ton. Assuming it can haul 200 tons for $10 million in kilograms, Starship comes out to $50 a kilogram, with the moon's launch cost at 5 cents a kilowatt hour, coming out to 6 cents a kilogram. Now that we set the operating cost, we can look at material cost. For this hypothetical, I will assume steel costs 5,000 kilowatt hours to produce a metric ton. For 5 cents a kilowatt hour rates, steel before export into space will cost $250 a ton, or 25 cents a kilogram. Adding in the launch cost to low Earth orbit from low lunar orbit, it will cost $313.41 a ton. Assuming someone wants to import 500 tons from the moon, it will cost them $156,705.54. That is cheap compared to Starship costs. How high do rates need to be to match Starship's launch costs of $50 a kilogram? Rates would need to be $49.50 a kilowatt hour, to match Starship's cost of $50 a kilogram. Overall, this system is a very interesting way to set the value of space-derived materials, being the energy needed to get the material to somewhere in a specific state in a specific place. I believe it solves quite a few transition issues with the scarcity Earth and the post-scarcity Moon. However, such a system doesn't account for everything, such as demand outstripping supply. Thank you for watching, and make sure to like, subscribe, leave a comment, and to share this video with others as an offering to the algorithm. Have a good day or a good night. I will see you later.